haven't gone over. And there's 2 questions that we haven't done in that package. Oh, actually, there's one more, which is not a big deal. We'll do it next time. Compositions and inverses, right? Compositions and inverses. So remember the composition of functions, right, is like putting one function inside the other. Usually, it's either, if we have 2 functions, f of x and g of x, if it says find g of f of x, that means take the f of x and put it inside of the g, right? Or if it's f of g of x, then take this and put it inside the other function. Right? It'll look, here's 2 actual functions, right? F of x equals x plus 4, g of x equals x squared. Find g of f of x, right? That means take what f of x equals here and put it in the place of x there, right? X plus 4, that's this, squared. Okay? If you go the opposite way, find f of g of x, that means take this and put it in the place of the x there, x squared plus 4. Do you remember that? Okay. Now, you might see this notation where they use this little open circle in between the g and the f. It means the same thing. To me, most of what I've seen that comes from them, they don't use that, but it is part of compositions. If they did, I mean, we can't say, oh, I didn't know that that's the way you represent a composition. We know that we can, right? So you don't look at that and think multiplication. If they mean multiplication, it'll be a dot. It won't be an open circle. If you get it in that notation, we usually rewrite it anyways, right? We would take g, open circle, f of x, and write g parentheses f parentheses x, and then deal with it like we've already learned how to deal with it. And then, so let's try this one. We're going to do both directions. Here's f of x, and here's g of x. What would f of g of x look like? Okay, so you're going to take this, put it in the place of x there, x squared plus 5 over 2. Right? What if I do the opposite direction? G of f of x, what is that going to look like? Okay, x plus 5 over 2 replaces the x there, and then it's squared. Now, you might also get something like this, where it's actually not asking you for f of g of x or g of f of x, but they've got a number in place of the x. And that could actually be easier, right? G of f of 2, I would write like g of f of 2. And then, since I know what f of x equals, it shouldn't be a tough thing to just find f of 2. Right? What is f of 2? Right? F of 2 equals 2 minus 5, which is negative 3. So replace the f of 2 with negative 3, g of negative 3. And then if you know what the g of x function is, this should be fairly simple to find g of negative 3. What'll I do? Negative 3 squared plus 1. 10. Okay, so here's, okay, then inverses. Inverses, right? Remember that an inverse function undoes what the function did. Like if the function is x squared, the inverse of it would be square root, right? If the function is x to the third, the inverse would be cubed root, right? They undo each other. The notation for the inverse is f to the minus 1 of x. Now, if you look on a graph, if you look on a graph, this is the f of x equals y equals 3x plus 2. That's this function right here. Right? The inverse is what you get if you switch all the points on here. Just switch the x and the y. Josh, do not. Put it away. Okay. So, for example, this has the point 0, 2 on it. The inverse must have the point 2, 0. Right? Every point on here, if you switch the x and the y coordinate, you get a point on the inverse. When you take another one, let's say this point right there. The x looks like about 2/3. The y is 4. 2/3, 4. So on this over here, we're going to go 4 2/3. Right? It should look like right? It should look like they are flips across the line y equals x. That line right there should be a line of symmetry for that graph and that graph. Right, that is the line y equals x. Right. Okay, here our function is, that was the f minus 1. Here's our f of x. This is the f minus 1 of x. So here's the point 0, 1, 1, 0. This point, 1, 2, 2, 1. Right? Every point on here, switch the x and the y. There's that. So what do you think, when we switch all the x and the y values, what's going to happen to the domain and the range? They switch, right? The domain of the function is the range of the inverse. The range of the function is the domain of the inverse. They switch. Now, if we have to find the inverse, then these are our steps. Right? If you start out with f of x equals, you replace the f of x with a y. If it already has y, then good. You don't have to take that step. Switch the x and the y, which switches the domain and the range, and then solve for y. Right? That's the inverse. Example. Right? F of x equals 3x plus 1. First step, make it a y. Second step, switch them, right? By doing that, y is not isolated anymore. So what are you going to have to do to isolate the y? Subtract 1, divide by 3. X minus 1 equals 3y. Y equals x minus 1 over 3. So f to the minus 1 of x equals x minus 1 over 3. This is one place that if you get this in a multiple choice format, there's a good chance that you're going to be able to solve it like this. Okay. Since we know what happens, a function and the inverse, their x's and y's switch, then if I can plug in a value for x and calculate the y, or the f of x. For example, what is f of 0? If f of x equals 3x plus 1, what is f of 0? 1. So it should be the case that f minus 1 of 1 equals 0. Right? They're just switching with each other. Okay, well, check these four. For which one of those, when you plug in 1, do you get 0 for an answer? Right? D. 1 minus 1 is 0 over 3, 0. I mean, check the others here. Negative 3 times 1 minus 1, that's negative 4. This one is negative 2/3. This one is 2. That's the only one that when you plugged in 1, you got 0. So without having to even go through all those steps switch the x and the y, solve for y. If you got it in this format, that's what I would do. I mean, that is what I would do for sure. If somehow it doesn't come up with the cleanest answers, you know, I can see sometimes if you get, for example, something that has like a radical. F of x equals the square root of x plus 2, right? If we were going to solve to find the inverse of that, I would put it first. I would put the y, then I would switch the x and the y. Okay, then I would square both sides, and then I would subtract 2. So f inverse of x equals the square root of, x squared minus 2. You know, they might have like that as one answer, or you might see sometimes, probably should have gone the opposite direction, like pluses and minuses on one and not on the other, which makes it, you know, in fact, you can substitute the same number and still and get it. You're just going to have to, they go back and actually do the solving of it. And there's another place, somebody said this, and I don't have any verification on this, that our method of substituting x equals pi and y equals e, that they're trying to be, like, have more than one of the answers that will have the same decimal. It's, you know, how would that be? Well, what if it said factor? And one of them wasn't completely factored and the other one was. They would have the same decimal value, but only one of them would be completely factored. That's why if you resort to that, you might want to like check them all, see if there's more than one with the same decimal value. All right, do the number 40 and 43. Not until we're done. Not until we're done. What do we get on the first one? A? How many said A? How many said A? How many said B? How many said C? How many said D? Wow, it's kind of scary. But the right answer is C. I mean, again, if this is the function, switch the x and the y values for a couple points and see what you get. I mean, if this graph had a point of 0, 2 on it, so your graph should have the point 2, 0, right? 2, 0. Which other ones have 2, 0? That has a 2, 0. That does not. That does not. So right away, it cannot be either one of these. Okay? This says the point 4, 0 on it. So this should have the point 0, 4. Which one has 0, 4 on it? Right there. So it has to be this. Right? Just switch the points, see which one looks right. Okay, find a composition. Which one? B? Okay. The right answer is B. Now, we're doing g of f of x, right? So it's we're taking this and we're stuffing it in there, right? So it's going to be 6 times, oops, I'm saying 6 and I'm writing something different. 6 times 2/3 x squared plus 1 minus 15. Now, in the end, that's not a really tough one to simplify. They can be harder than that. You could have foiling to do and things like that. But at that point, you might use the x equals pi, see what that equals, and then just see which one of these is the same. Right? If there's any question about how to simplify that, like that would work for you. In this case, the 6 times 2/3 is 4x squared. Right? 3 goes into 6 twice. 2 times 2 is 4. 6 times 1 minus 15, so 4x squared minus 9. Answer. So I'm going to give you one more.